Mic check? Yeah. Yes. In the back? Everyone loud and clear? All right. We're going to talk about full stack type safety. There's this thing called TypeScript in the JavaScript world. And with that, we can add type bindings to React. We can also have type bindings on the back end with GraphQL. How many people have heard of GraphQL? Okay, very nice. Lots of hands. And then there's this other last piece of last project that we're going to be using called Type GraphQL. How many people have heard of that? Okay, not as many. Great. Then that's what I'm here to talk about, because really Type GraphQL is the star of this. Oh yeah, okay, this is me. I'm Robert. I'm a technical evangelist at Amazon Web Services. My Twitter is right there. DMs are open if you want to get in touch. And I'm really proud to announce that last year I became a published author. I'm very proud of my... This really is on Amazon. You can search for this. I'm not kidding. All right, so I'm going to show you the code very shortly. We're going to be in VS Code a lot, and to kind of set the stage of what I'm showing you, I really set off on this project to ask the question, what's the ideal development experience for breaking API changes? And I know that's like, what is the best development experience for eating glass? But it's a problem that we face a lot, right? And especially if we're building websites, we've got React chugging away on the front end. Organization is not a problem. We understand how to manage state. React's been around for a while. All the most common questions like JavaScript fatigue, I think those are all behind us gladly. But nevertheless, if you have your React application, it's talking to some sort of endpoint, whether it's REST, whether it's RPC, whether it's GraphQL. If you change that API in certain ways, for example, you have a function that requires 2 parameters today, and you ship a new version that now requires a 3rd parameter, and it would fail unless it received 3 parameters, and that's an API breaking change, right? Or if you rename a variable or you retype a variable, those are API breaking changes. And it doesn't really matter what API technology you choose, you can hit these problems either way. So I have the code on this repo right here. If anybody wants to follow along, unfortunately, it's going to require 2 npm installs, lots of package dependencies. So I don't know if the Wi-Fi can handle it. Show of hands, anybody actually want to follow along? Nobody? Okay. All right. Wow. Is that because we've all been burned by npm installs at this? No? All right. Okay. I'll just show you. Okay, so let's go to the code. All right, if you clone it, you would have these 2 folders, API and dub. And I put the GraphQL server behind API. And I believe it's running right now, so it's running with hot reload, both the GraphQL server and the React application. So I just want to show you the React application, and we'll go through what this thing looks like. Okay. Yes, it is another to-do list. I'm sorry. This is just the thing that everyone gets. So very simple, as you would expect. You can add a list here. And then we can say, all right, so I can add any items that I want. I can check them off, and then I can clear done. So that's the functionality. Now, this whole thing is powered by a GraphQL API running on localhost. And let me show you what that looks like to use first. So you can see this is my schema on the right here. For those of you who have not used GraphQL in a while or this looks foreign, let me go over it really quickly. It's just saying that this entire system, it supports these mutations. I can add a list. I can add an item to a list. I can mark an item as done. I can clear done items. And we saw all those in action in the very quick demo of the front end, right? It's saying that whenever I create a new item, I should specify this new item input. And I should specify the list ID, the list to which it belongs, the name of the item, and then the description of the item. The rest of it I'm not going to go through all the way. But this is GraphQL. This is a GraphQL schema. The GraphQL schema is saying, here's your API, here are the operations you can do, and here are the input types and output types. And for each type, what is its relation to other types, and what are its scalar fields? So with this, you kind of have this graph that also acts as a type system. Because you can see here, for example, the new input item, it's saying all three of these fields are of type string. Right? So this is above and beyond what vanilla JavaScript gives you already. You have all this type information in GraphQL. So how can we make use of this? Well, the first thing is, of course, that in our React app, we need to set it up so that we have TypeScript configured. And you can see here, I have a tsconfig file. I'll let you go through it at your own pace, but you can basically run it as though it were a React app, except all the code that you're writing is TypeScript files, it's .ts files. How many people here use TypeScript? Okay, cool. It's a lot of hands, but a couple of people still haven't encountered it yet. So TypeScript, just compiles down to JavaScript. And the way that it compiles is specified in this ts.config file where you run ts. And then everything else, really, this is stock create React app with specifying the TypeScript flag. Okay, so let me show you the server. How did we set this up? Actually, how about this? Let me show you the API breaking change first, and then with whatever time we have left over, I'll tour through the rest of the code, because I promised that was the whole point of this, right? So the API that I'm going to break is the one that uses this thing, add item. Let's break this API right here. Okay, so when I add a new to-do item to an existing to-do list, let's break this API by requiring that the new item input take a fourth parameter. Make sense to everyone? Okay, so when we do that, then in the future we should see, right after we make and deploy that change to the API, we should see the React app break somehow. We don't know how yet. Okay, so let's go to the code here. The way I add this is using type GraphQL, and hopefully by adding it, you'll see how intuitive this thing is. Oops. So I've got my list of resolvers here. And if I scroll down to add item, you can see that I have these experimental decorators. This is also a TypeScript feature. And with this decorator, I'm saying that this add item, this is the one that I want to change. I want to add this to the schema by way of a mutation. And when I execute it, I return a to-do item. And then otherwise, it's just wrapping this add to-do item and passing the input argument. So in order to break this API, we said we want to add one more field to this thing. So let's add one more field. And we'll say priority. It's of type number. And I'm going to add this. This, again, is a type GraphQL decorator, this at field decorator. And by adding this, we're saying, hey, type GraphQL, you should expose the priority field as part of the GraphQL schema. Right? So if I save this, I come back into graphical. Now when I look at the schema, we can see that new input type has a fourth field, mandatory field called priority of type float. Okay, so GraphQL, type GraphQL, and GraphQL have worked together to determine that if you use the TypeScript type number, that'll map into the GraphQL float. Just an interesting thing to note. All right, now when I execute this add item mutation, it's not going to pass in priority because I didn't make any changes to my front end. So let's give it a shot and see what happens. Okay, so it didn't actually, we don't see the break API item on this list, but we do see a failed network request over here. Right? You can see variable input got value this, and then field value.priority is a required type float, but was not provided. So this is already we're doing pretty good. As far as APIs go, I mean, I could have just gotten a cryptic, right? I could have gotten a cryptic like 400 and something broke, I don't know what. At least this is telling me, this is exactly what I would expect to see at the API level, and this is just showing up in the browser. So what if we could do one better? There still appears to be no easy way. Now let's say, I'm seeing this code base for the first time. Oops. Let's say I come into www, and this is where my React app lives. And I'm looking at app.tsx here. Where do I need to, what do I need to fix? Right, because I found this error in the dev console in the browser, but I don't actually know what I need to fix. Where's the type breaking change in my www folder? I don't know if you can see this down here. I have a terminal tab open, and it's running hot reload for this Create React App project, but it's not showing me any type errors. Wouldn't it be nice if the React app told me exactly what was breaking before I ever had to run it and do a manual test? And luckily, we can achieve that. So inside this folder, inside package.json, you can see that there's another script I added here called GraphQL CodeGen. And what this is going to do is it's going to make an API call to that GraphQL endpoint. And it's going to pull down all the type information, just like we saw in that schema. And one of the types that it depends on is this new item input. And so when I run CodeGen, by virtue of pulling down the GraphQL schema again, it now has the updated definition of input item. And when we do that, let's see what happens. Okay. So I've pulled it now. And then, of course, when you do this, if you want to follow along, you can always do a git diff here, and you can see exactly what npm run CodeGen actually did in terms of what it did to the client-side generated files. But now, if I watch the project, oops. Let's see if anything broke. Okay, so now when it ran, it says property priority is missing in type, and then it's giving me a type hint. It even shows me exactly where this is. Everybody see that? So that's pretty informative. That's even one step better than what I saw in the browser console by manual testing. This is great. I said developer experience. What I really mean by that is I want to find errors as quickly as possible in the dev test feedback cycle. And here, I mean, what better? Because this is running the type checker constantly whenever I save a file. So whenever I mistype anything like the input, I get this terminal yelling at me immediately. So let's click and follow through, and it says, hey, this thing. Look at that. And by the way, this is all TypeScript, right? Because we generated the client-side typing. So it would be as if you went in there and added a TypeScript interface or a definition somewhere, and then you tried to pass that in, and you didn't pass the correct the shape of the object. So it says priority is declared here. Where's priority coming from? All right, let's hard code one for now. Let's see if it works. Okay, you got a warning about a React hook use effect, but no errors, right? So now if I come in here, well, there's one problem. We're using a browser prompt, so we don't have a UI field to enter priority, but that's okay, right? We've got it hard-coded for now. It's all good. And you can see that it's working again because I am providing that value of 5 as the priority, as the hard-coded priority for all new items that I create. Obviously, that's not the intention of the priority field, but now the next step is, okay, what do I do to my React components? What do I do to my UI? What do I do to that page so that I can light all this up? Make sense? Yeah. I guess the rest of this is kind of a choose your own adventure. That's really what I wanted to show. Well, okay, let me take a step back. One of the reasons I did this was, this is actually a remarkably similar way to how we wrote code at Facebook. So I used to work at Facebook. I used to work on the GraphQL team. And what we had there was a developer experience similar to this. And I thought it was a very good developer experience. I thought the idea of going in and editing your API definitions, and you can see what we were editing is not GraphQL schema. We were not writing GraphQL schema, right? When we were making that change to new input item here, this is as if we're just writing TypeScript. It's very close. And if you're wondering, well, how do we add an arbitrary field to the schema, we can do that too. We don't have to just add additional scalar fields to existing types. We can actually add a root field. So you can see that all these things were root mutations, right? So it's very easy. I can come in here and say, I want a query that returns a string. Oops. So if I do this, I've added a root field of type string called hello into the schema with just 4 lines of code. Let me save this and show you that it's actually working. So now when I click docs, I can see the hello string in here, right? And I can run it like so. And that shouldn't surprise anybody. So all we did was write this, this root query. When I leave out the operation type, GraphQL infers that you're trying to run something up. So this is identical. And then we're saying we just want to fetch the field at the root called hello. Right? So this is, when you write, what I'm trying to demonstrate is that the code I was writing here, these 4 lines of code, this is not GraphQL code. So your development experience actually doesn't involve writing GraphQL by hand. And I mean, at Facebook, nobody wrote GraphQL by hand. It was always auto-generated. It was always, you have a layer where you're defining your business logic, very similar to this. And then it was going through and generating that schema so that there's no opportunity for anybody to make any mistakes by defining the schema in one way and then having the code that backs it up work a slightly different way. That was a source of bugs, and it was easy to make, so we decided that that was not the right way to do it. But that's not to say that other people shouldn't do it. We just had problems with it. But you can see here that this is now either adding new types, new entry points into the schema, or adding new fields to existing types, changing their names, changing their types. This just looks like writing TypeScript. And you're not really thinking about, you're not context switching from one language to another. This particular demo, it's just TypeScript all the way through. So it's TypeScript plus GraphQL on the back end, TypeScript plus React on the front end. Are there any questions so far? Okay, you're gonna have to shout it out. Question in the back right there?
Sure. When you ran CodeGen, did those files that in CodeGen, did something that file system
I'm sorry, you're gonna have to speak up. I missed the second part of that.
when you ran CodeGen, the files that it generated, did it put something in those files that this is an
Yeah. It definitely. Let me show you that.
Can you repeat the question?
Yes. So the question was, when you write CodeGen, is there some way to know that the file has been automatically generated? Okay. Yeah. So we should just be able to pick out the files here. So when you ran CodeGen, what you got was this. Well, what I configured it to do was to put all the type definitions into this generated.tsx file. And you can see that this is the file that you're not supposed to touch because the code generator is going to override it every time. And in fact, we can see that this file, this type that we pulled down here, this is what was changed exactly.
How does the code generator know about inputs and stuff like that? Because those are kind of like your forms on the
No, they're part of the GraphQL schema. So when you,
Oh, yeah, you're right.
yeah, yeah. So input types,
Yeah.
exactly. Anything that you see here when you open up the schema tab in graphical, so just to get a little bit more technical, the way that this is working is that GraphQL code gen step is running another project called GraphQL Code Generator, and this, as the name implies. Um, and so this thing is originally designed with generating these types and then also generating the React higher order components. So if you actually do a git diff after you run CodeGen, you'll see it just placed these higher order Apollo components, assuming that you're going to be working with Apollo server. But we're not. We're just doing it all hands-on. But what we can use is the raw TypeScript definitions that it generated. And maybe there's a better way to configure it so that we don't get those extra classes. Okay, let me go over a few more slides that give you a better idea of what we're working with. So on the server, the process that's running the server, what I have here is Node.js process, obviously. But then I'm using Apollo server, and then I'm using this project called TypeGraphQL. So if you just search npm for TypeGraphQL, you'll find it immediately. And TypeGraphQL is the thing that's actually doing a lot of the heavy lifting here. Notice that we didn't talk about Apollo, we didn't talk about the schema, and that's because when you start the Apollo server, you have this function build schema, and the build schema function, you pass in all the resolvers. Right? So the resolvers are the pieces of logic that back every individual field. And when you pass, what you're really saying here in this project is, instead of passing in your own resolvers, you're passing in objects that are annotated with type GraphQL annotations. And now the conjunction of type GraphQL and build schema will know how to basically parse that out. So if this is the server, let's take a look at the client. Here, of course, we have React. The project was bootstrapped with create React app and the TypeScript flag, -- TypeScript. And then I added the GraphQL code generator. When you run GraphQL code generator for the first time, it'll run this config CLI for you. And you can basically specify what you're using, whether you want TypeScript bindings, whether you want React bindings, whether you want Angular bindings. So this is not like GraphQL code generator is front-end agnostic. It supports lots of different front ends, but always, in this case, we're using it specifically with React and TypeScript. The other thing I wanted to show that I think is kind of clever. I mean, I know there was a talk yesterday on React hooks. How many people here want to take a look at how we did the state management for this app? Okay, state management, always an interesting thing to talk about, right? Okay, let's take a look at state management. So at the entry point here in my app.tsx file, this is, well, we can look at index if anybody really wants to, just to convince you it's very boring. This is the true entry point, to be pedantic, right? And so it's pulling an app, and then we get to app. You can see here that I'm setting up this store, and I've created a custom hook here called use store from provider. And this is a function that I wrote that I wanted to show you how I do state management. But before we drill into this, once I have this store object, you can see I'm using the higher order component provider pattern right here. Right? So now what I'm saying is everything nested under this element is going to have access to the store that I initialized up here with my initial list of empty list. Right? So let's take a look at how we use this thing further in. Let's see, let's say grid. Oh. So now everywhere in my, and by the way, I'm using pure function components everywhere, right? So this you can see that the exported value is just an anonymous function. It's taking in props, and you can see that we're also using TypeScript, TypeScript plus React to specify the type for props. This is really handy so that you don't mistype your props. And then once we're in the function call, we can call use store, and that was all set up. I can call use store from any component nested under the store provider that I initialized in app.tsx. This is the higher order component pattern. We've seen this around for a while. But now with this store, let's take a look at where I use it. Now I can just call this, I have this function called store.refetch, and what store.refetch will do is completely refetch all the states. So it's actually being quite inefficient right now. Right? And here it says, this is where we made that change to add priority. And what we're saying right after it is, right after we successfully add that item, let's not worry about patching up the client-side state. Let's just completely refetch it. There's probably not that much data in a to-do list anyway. So this is kind of a heavy-handed way of doing it. And you can see here when you do any mutation, really, the way it's keeping the client and server state in sync is by calling store.refetch. So lots of overfetching, but for an app this small, it doesn't really matter. But the cool thing is that this store object, now this store object can control all of the logic to do with dealing with the API. Let's take a look at refetch here, for example. And you can see that here we're just calling get all lists. And this we know is a GraphQL call, but get all lists, let me show you what this is. This is a very, very thin wrapper around the generated code. So this is get all lists query. This was auto-generated from running CodeGen. I just threw this very, very lightweight wrapper here that, and the only reason I needed it was because I want to bust the Apollo cache. I'm using Apollo client as well. And so I just want to say, hey, by the way, I know this data might be cached after a fetch, but I don't want to use the cached version. I always want to make this request out to the network. So this is an inefficient request, but I mentioned before, it doesn't really matter right now.
So are you not using the cache for anything?
No, everything else uses the cache. But it's kind of a moot point because this function effectively blows away all of the state and then replaces it with something else. So maybe the missing piece is you might wonder, well, how exactly am I updating the state? If I'm calling this thing, and I'm calling refresh, how did I update this state object, this store object? And you can see it's kind of hacky. It's calling this, it's making this network call, and then it's setting this.lists. And somehow it's saying, okay, I have a new lists property. How do I notify everybody who's observing this thing? I mean, it doesn't really quite work like that, but how do I basically tell my prop tree, my component tree, to re-render itself because I have a new state? And the way it does that is just this refresh call. So if you do refresh, it calls this.set store. And this is the React store pattern, right? So now you can see that all of this stuff is just, all that use store from provider, the custom hook that I wrote, this is just using the React store pattern. So you can see right here, this should, sorry, the React context. Yeah, the React context pattern, I misspoke earlier, but this is the context is, I don't know, anybody here use React contexts? Okay, it's a lot of people, but basically this is another, any chance the talk yesterday went over create context with hooks? Okay, I'm not gonna talk about it then, all right, it's good enough. Yeah, and then use store from provider. So this is, okay, let me cut to the chase. This is just a really, really simple pattern when you have very little state. But if you're going to salvage ideas from this project for your own project, just a word of caution that as the store gets bigger and bigger and bigger, if you have a lot of state packed into the store, then this kind of heavy-handed, set store with a brand new object with all the properties passed in, this is not the best idea. I mean, just keep an eye on it. But when you're dealing with very little state, this is fine. So what this does, this makes everything completely seamless. So every time I'm developing with the state, the store will, I know that I have an object where its reference will always change whenever I update anything about the state, and therefore all of the related components are going to re-render themselves. That is pretty much all I have. I know that I kind of glazed over TypeScript and GraphQL. If anybody wants to see more GraphQL, or this is like more GraphQL in the back? Okay. All right, we can look at more GraphQL. How about we add a query that takes a parameter? I guess this is more of focus on TypeScript, type GraphQL than it is on raw GraphQL, since we haven't actually been writing any raw GraphQL schema. But let's say that we wanted to have hello return a string, like it'll just take name. I think you all could write this code yourself, right? Do I really need to do this? Maybe we want to yell it out. What am I typing here? Name colon string. Oops. Do I need the @arg? What do we think is going to happen if we just run this? I don't know. Let's try it out. This is, yeah, I think so too, but I just want to see what happens. Yeah. So it still says hello, takes only, it still works. I mean, it's undefined. That's what we would expect, right? So yeah, this seems to make sense so far. Now we can come in here and we can say, well, actually, I do want to let the caller pass in this name, right? So it's @arg. And then we have to give it a name. That's a little bit annoying. I should know. Okay. Oh, look at that. We need an argument name now. That's pretty cool. So let's go over real quick. How do we pass a parameter in here? That's it. That's all it takes.
Can you make it optional?
Can you make it optional? I believe you can. I think it has something to do with this. Oh, you're right. You're right. It would be on the arg. Yes. Validate options. Okay. Anything? It's nullable. That is the name for optional parameters in GraphQL. So now when we open the schema, you see, so now we have the nullable string, and we know it's nullable because it doesn't have the exclamation at the end. So now I can call this like so. Or that. Right? Pretty easy. And then obviously, oh, well, one thing I want to point out is you see we have the option of tagging these functions as either async or synchronous. And they behave as you would expect. Right? There's no deterministic order in which GraphQL will go and execute all of your resolvers. But it will respect the asynchronicity of it. It will make sure that to wait for all the outstanding promises to complete before it sends the response, so you're not going to have some partially assembled response. And then because it's async, it's extremely easy to come in here into any one of these functions and have it talking to a database or a file or a cache or running compute, whatever you want to do. Just to underline the point that a resolver isn't anything special. It's just a regular function. You can return any value you want, and you're just using these annotations to give type GraphQL a couple hints about how to turn this thing into a GraphQL schema. Okay, any other questions? No? All right, I'll put the URL for this thing there one more time in case you want to play around the project. And thank you for listening.